Thank you very much for joining us today. In this session, I will talk about the common distribution technology that supports the front end of Yahoo Japan Shopping. I'm in charge of the Yahoo Shopping. My name is Konaka, and I also have Mr. Tanaka with me. So let's get started. So this is today's agenda. First, I will talk about how the common UI distribution service was born. And secondly, I would like to talk about the supporting technologies of this common UI distribution service. So let me start with the circumstances leading up to the birth of this service. At Yahoo Shopping, there are various screens. So for example, the top page or landing page, search, product details, shopping cart, review, and contact us, and products and campaign. In addition to this, there's a ranking and order history. So accordingly, there are different development teams. Now, each team has a different applications which are independent, and they are connected with links. When the applications are different, the common UI or HTML are described differently or separately. So within one application, it's easy to implement the common UI, but across the applications, even if the UI is the same, we need to implement them individually. So for example, this is an image of that. So from the top page, you enter keyword and you do the search. And you will be transferred to the search page that is created by the search team. And if you click on the product, then you will go to the product detail page that is created by the product detail team. And they are connected only with the hyperlink. This configuration has existed for a long time. And what is shown in the red square, this is a similar layout part, and they are implemented individually. So let me expand this portion. Now, common UI is this part. So the UI across the multiple pages, for example, headers and common notification and the search windows are included. So in the situation where you want to modify the common UI, what would happen? So you want to get people involved together and explain the specifications. And it's difficult because there are many people involved and a lot of work to identify who they are. And even if you manage to do so, it's difficult to find the time available for everyone. But it's inefficient to repeat having those meetings. Say that you have managed to have a meeting to explain the specification, but of course each team has a different tasks and the resource availability is different, so the timing of the development could be different from each other. So it would be difficult to have a same launch date or release date. Now that we progress in the process, you might find that there was another team who should have been involved and say that the release is complete, but you might find the difference of the layout between the different pages. It's very difficult. Making the simple modification is difficult as is. So it was an exaggerated simulation, but I'm sure that you have experienced something similar to this. When all the pages of the web service are distributed from one application, then the common UI can be prepared easily. If that is the case, the problem like this will not occur. But as the size of the web service expands, you want to divide applications. And at that time, an issue like this could occur. Under those circumstances, there was a company-wide large-scale refactoring order. And this is led This has led to the shift from the old system and the review of the computing and switching of the languages to improve the productivity. So front end was reviewed and common UI distribution system within the shopping was built.
That's why we created common UI distribution system, PTA. There are 3 major services in the common UI distribution system. It's been 3 years since we began operating this system. And what you see here is the current situation. We have improved multiple times, but if I talk about the history, we will not have sufficient time, so let's skip that. Going back to my presentation, I want to talk about different services one by one. PTA Commons. This is not the UI, but this distributes the logics closely tied to building UI in a library format, getting and processing user information or allowing or denying logins. Some of these logics are made common. Next, PTA v2. This is the reason for the creation of the original PTA. This is the distribution service of a common UI for almost all screens, distributing header, footer, or search window. As the name indicates, there has been substantial modification since the old version, since this is v2. Now, module service. This is the late-coming service. It's not the whole screen, but top page, search, and application. All of these use common migration modules, and these can be distributed by this module service. Migration module is really to promote migration within the page, lining up the recommended products. Currently, campaigns and features and sales are actually rendered by this module. Because of the limited time, I cannot cover everything, so I'd like to focus on PTA v2. In order to create PTA v2, these are the things that we wanted to enable. First, reducing man-hour. The goal here is to reduce the cost of coordination and multiple development, which are the biggest advantage of the common distribution. Next, unified layout and specifications. We want to eliminate misalignment or implementation errors. And also changes made in the front line. Being able to change without any front-end work. This is related to man-hour saving. By changing the common UI, we wanted to minimize the change needed on the front side. Once the team deploys the UI, as far as the interface does not change, they should not have to worry about the front-end work. Next is no limitation to the front-end language or FW framework. We made sure not to restrain the language or the framework because of the common distribution system. Next is the use of React. This is very specific since we have unified atomic design plots for shopping and distributed them as React libraries. To take advantage of this, we decided to use React. Lastly, not to compromise UX. This means that as a result of introducing common UI distribution, this may result in poor performance or loss of quality user experiences. So let me talk about common UI. We have to resolve these problems. These are the requirements. What can we do? The result is to use micro frontends. The link here has a sample implementation, and this was very, very helpful. So what is the micro frontend? This is the overall image of micro frontends. One single page is composed of multiple products. For each product, each team can choose any framework they like. The benefit is that change can be made step by step And it's very simple. It's loosely coupled, which means that it can be independently dealt with. What it means is the benefits of the back-end microservices to be applied to the front end. This is a recap of what I have explained. This is a common structure, but it's a pattern of micro front ends in a wide definition. The top page, search and product details, have separate teams and different applications. Their architectures are different. The language is different. Deployment can be done independently. The strength is its simple structure, but duplicate development of common UI was a disadvantage. In order to overcome this, we decided to maintain the existing structure, and for the common UI, we would distribute the one prepared by the common distribution team. Let's apply that to the other requirement.
The work process reduction and unification of the layout and spec can be achieved since this is made at one place. If loosely coupled, independent deployment is possible and change can be made without front-end work. And on the single page, you can use the multiple frameworks. So that means that it will not limit the language of the front end and the framework, and we can use React. On the front side, you don't have to ask for React. Whether UX is compromised or not, this needs to be considered separately, so we would like to put that aside. If you use the micro front ends approach, it seems that we can clear most of the requirements. So we decided to use React for the micro front ends. So now I'd like to invite Mr. Tanaka to talk about supporting technologies of the common UI distribution services. Tanaka-san, please. Thank you, Mr. Konaka. So I am Tanaka. I'd like to talk about the technology supporting the common distribution technology. In the case of Buta for the micro front ends, well, concerning micro front ends, I'm sure that you are hearing about this often, but most of the articles that you see are based on the SPA. So shopping is a non-SPA, and we don't really see many articles written on that. So this time, we tried micro front ends of non-SPA. So I'd like to show you some of the code samples that are actually implemented. So if you look at the sample code, you'll be able to do the similar implementation. So let me first start with the system configuration. The factors are shown in blue rectangles. On CDN, there are JS and CSS. And to return the content data for the common UI, there is a dedicated BFF. BFF stands for Backend for Frontend. So this is a simple REST API. Now, as a flow, Frontend receives the request of the browser and returns the page HTML. And from the browser, JS, CSS located at the CDN are loaded, and a React component does the rendering. And content data is acquired via BFF. So this is a usual configuration. But you don't understand anything from this, so let me go deeper into the content. Let me talk about front first. So this is the HTML that will be returned. As Buta is asking front to do the work, so we want to make it simple. Now, from the top, link tag is used to load the common CSS. And here, the common UI style is defined. Next, with script tag, the core JS of the Puta is loaded and instantiation process is added. Core JS has the React instance shared in the common UI and also the processes that are used across UI. As for the instantiation, the different values for pages are given. Lastly, the tag addition at the UI component. The set of custom element tags and SHAP header, for example, here, and JS script tag that loads the JS are added. And if the parameters are needed, Oge or Fuga, those can be specified by attribute. And the number of the sets is based on the number of the common UI needed for the page. So on the front side, adding the framework is not necessary. So introduction cost is not so high, therefore. And when we say custom element, you might think that it uses the web components, but it is not used for UI implementation. As it said in the requirements, we use React for UI. So I'd like to show you what we do actually. So after receiving the page HTML, the JS and the CSS are loaded on the browser, and the React component is rendered. And from each component, content data can be acquired. And after loading JS and CSS, this will be the implementation inside the Puta. So we talked about the custom element on the front side. So this needs to be React. So this part of code looks like this. So for each UI, right after the JS is loaded, this is executed. So first, custom element class is defined. And custom elements defined with this, it is added.
Then connected callback, lifestyle callback gets called. And to mount React, we would create a container, and props will be created with attributes. And then React will be rendering and add below custom element. This is the overall flow. So when a tag is placed, rendering will take place. React components can be implemented in the usual way. So with this, micro frontends has been implemented. So the characteristics of Puta system are first, runtime rendering of UI with custom element and React. So on top of the browser, you can create UI. This is a regular implementation pattern of micro frontends. And then this is framework free. In order to implement micro frontends, there are frameworks and libraries that are available, but we did not use them. React is also hidden from the front end, so there is no framework needed for the front end. As I showed you, there are many different frameworks and languages for the front. We did not, we excluded unnecessary things. But this is not the end of it. There are things that need to be cleared and solved. That is the last requirement, not to compromise UX. The biggest problem about the UX was the layout shift. Especially the common UI that is displayed on the first page. If there is a layout shift, all of the shopping sites will have the same problem. To minimize this, we needed server-side rendering, SSR. So what could we do? We looked for answers in relation to micro frontends. Nothing interesting was found. We explored different ideas, but eventually For the first UI, we chose isomorphic implementation. This is a difficult word, but this means that UI is rendered on the server side and client side, the same UI. Next.js is a very famous framework that implements this, but without this framework, with React, it is rather easy to implement this in the browser. Since this is for SSR, we will be able to solve the problem of layout shift, and it functions as a regular React component in the browser. In order to realize this, we added one element to the earlier system configuration, that is SSR API. On the front end, through this API, UI gets an HTML fragment. This HTML fragment is rendered with the same React component as used in the browser. Therefore, what is rendered here would be the same between SSR and CSR. That said, the way of generating page HTML on the front end is a bit different. SSR has been added, and HTML fragment and initialization data are pasted on this. Earlier, the parameter assigned by the attributes of custom element tag become SSR API request parameters. From SSR API, HTML fragment and initialization data will be returned, and they will be pasted in the respective designated way. It has changed, but not so much. Along with that, React component in the browser, the rendering changes. The biggest change would be the props being generated from initialization data. The left-hand side, you see the CSR. On the right, isomorphic version that I am discussing. Initialization data includes the parameters and contents that are used during the SSR. Using them, the same thing will be rendered in CSR. The lower part of this is really the replacing SSR with CSR. It is a pasting. You don't have to replace it. You might think that there's no need to replace the SSR HTML, but SSR result in static HTML. Even with event handlers implemented with React, they will be all gone. This limits the range of UI expression. So we replaced it with a React component to make sure the event handlers function. Now, when it comes to the details of React, I talked about the isomorphic. You might be thinking of using React Hydrate, but here we used createthe. This is related to the overriding without updating the .js version in order to eliminate the front-end work. So what do I mean by this? So hydrate, we have SSR and CSR. DOM structure must be the same. That is the assumption. When releasing the change in ptar, Hydrate cannot update SSR API and the React component used in CDN.js at the same time. So there may be a slight difference that makes it difficult to hydrate. That is why we use the create element. So, isomorphic SSR is also added eventually. This is another characteristic. With regard to SSR, we needed it because it's non-SPA. So it's a major characteristic of ptar as well. Adding SSR API will increase work done on the front-end side. And there will be stronger binding. It's a disadvantage, but I believe this is a necessary trade-off to be able to satisfy some of these requirements. So this is so much for the technical details. SSR is a bit complicated, but it's not so difficult. So let us try to summarize that. Before summarizing, I'd like to talk about some of the effects. First, we've been able to reduce the development cost. Compared to 2021, we were able to reduce the cost to 1/8, and we were able to reduce 20 months per year. And communication costs are very difficult to show in man-hours, but we have been able to achieve the communication cost reduction in a qualitative manner, and we are able to reduce lead time. For example, link URL change, we're able to actually complete that change within 1 hour from development to release. And then we have been able to increase the number of front-end deployments. Framework has been renewed, so it's not the sole effect of PTA alone, but we have been able to concentrate resources to where we want to carry out our work. So this is a pleasing effect. And since we're talking about common UIs, it is easy to scale, and we have been able to produce positive outcome. So the summary. I've talked about micro frontends with non-SPA, including real implementation. I hope you enjoyed my talk. We really wanted to work on micro frontends. Then this involves team reorganization and optimization. But as you know, the shopping is a large scale. It's not easy to get there. And we did not go as far. However, there are many cases in which we can be happy enough if we can adopt the micro frontends approach, even if we do not go that far. So the key here is doing well. In the end, the optimum solution will differ according to each individual circumstances, but we have done well, and I think we are a little bit happier. So I hope this is a good example for your reference. Thank you. This ends my presentation. Thank you for listening.
Thank you, Mr. Konaka and Mr. Tanaka. So now I'd like to start the plus talk. The interviewer would ask the questions that he had during the session. We would also take questions as much as possible from the audience. If you have any questions, please use the question mark from the bottom of your screen to upload your question. The interviewer is Mr. Hiroyuki Shibasaki of LINE. Mr. Shibasaki, please introduce yourself. Hello. My name is Hiroyuki Shibasaka of LINE Kyoto office. Thank you very much. So what were the questions that you had as you heard this session? Well, in the past, there were similar difficulties that we faced. So I really enjoyed listening to these presentations. So first question that I'd like to ask you is that, so this time you introduced the technology, and are there any other candidates? Well, originally we operated this for about 3 years, and we updated it. We went through the version improvement, and initially use of React is the same, but the JFeasy was used, and library distribution, that is the user information, the acquisition of that was created as a service. So inside the PTA protocol buffer version, there was a dependency there. So because of that, for the common UI distribution, especially there are various screens, and it was difficult for this to be utilized. So how to introduce this simply and how to eliminate the dependency to make it simpler is something that we try to do. I see. Anything that you want to add? In terms of our technology, and in addition to React, Angular, and Vue were used. And in our case, use of React was already decided. The reason for that is that the common UI library was created with React. So we decided that we would use that. So the first choice was React. Thank you. Well, the server-side rendering was mentioned, and during your talk, layout system, you wanted to prevent that? I think you said that. So server-side rendering, as you introduced it, what were the benefits, or what were the disadvantages did you find? Well, the communication cost is there at the beginning. So in comparison to CSR, so it's a trade-off. So layout is a common UI. So when it increases, layout shift. So preventing that was more important. So SSR was utilized as a result. So that is the telecommunication related disadvantage was one of the things that we noticed.
Next, I'd like to ask you about CSS. Common CSS is on the distribution. So on the site, you have common style and common UI style. That includes both styles. Yes. So common CSS distribution means the whole site style can be maintained effectively. Having said that, it's not exactly micro frontends. At least this is my impression. How have you come to this structure? Well, rather than getting this situation or trying to get that situation, this is the current challenge. We are collaborating with design system people. We are trying to eliminate dependency on CSS. So that's something that we need to implement so that you can come closer to micro frontends. Yes, dependency on CSS is not what we intended to do. This is not a technical question, but introducing the system, you have been able to reduce the cost to 1/8. This is a huge saving. How did you measure the impact? Did you have any problems in measuring the effect or outcome? How did you set KPIs? Can you talk about that? Yes. When it comes to KPIs, it's not that we measure small, tiny KPIs or detailed KPIs, but since this is common distribution, common UIs after implementation, how much change has been made without causing a lot of resources on the front end. So we sort of multiply these numbers and try to understand the size of saving when we construct each one of these separately. Now, we'd like to also answer some of the questions asked by our viewers. Next.js. Without using Next.js, we use React. Why did you choose React over Next.js? Well, this is because Jumping Frontend is made of different pieces. Next.js, there are some pages of that. We use VHS and Java for other pages. But if everything is made of Next, that's not a problem, but it wasn't the case. And next, it's going to create one single page as part of front-end framework. But this is a common framework. So we decided to use React instead of Next. Thank you very much.
Next question. The common UI, without specifying the version, make it easier to distribute was mentioned. But choosing the certain version to use, is that possible? Well, so far, basically, we do not have such operation. Say that there is a kind of disruptive change, the version needs to be changed, and the implementation timing on the client side is different, so we can do this in an arbitrary manner. So we would increase the version, but basically we would rewrite the same version, so the client side work would be will not be necessary. So that's one of the advantages. So far we haven't had any need to choose the version rather than upgrading. So that when there is a disruptive change, maybe it might be necessary. Also, this is the last question. Puta, the name, what does it mean? Well, why Puta? Some might wonder, but the shopping system is the name of the Egyptian god. There are many cases like that, using the Egyptian god's name. So, Hos, Ru, and Puta means that the god that would unify south and north. So we thought that's the. I'm sure. I think that the name was chosen because of that. Probably yes. So make it common. It's a god for unification, so to speak.